This is Cambridge IGCSE for Paper 2, Multiple Choice Extended, Chemistry, from February-March 2021. Question number 1. Which row about a change of state is correct? So let's check one by one. Solid to liquid actually involves heat taken in, not given out. B, gas to liquid should be heat given out. And then C, solid to gas is indeed heat taken in, and then the process is sublimation. That is correct for C. Right? So what about D? Let's check D just to double check. Liquid to solid is heat given out. Despite that is correct, but the process is wrong. That will be freezing. All right, so remember, if the particles are converting from a less arranged form to a more arranged form, so that will be a heat given out process. Okay, whereas going from more arranged form to less arranged form, there will be heat taken in. All right, moving on to the next question. 2, gases are separated from liquid air by fractional distillation. The boiling points of 4 gases are shown. Which gas is both monoatomic and a liquid at -200 degrees Celsius? Well, the word monoatomic tells you that it's a noble gas. So you can pretty much eliminate nitrogen as an option. And then liquid at -200 degrees Celsius. So essentially, you can draw a number line. Okay, a number line in terms of temperature scale. Put -200. All right, so essentially, this temperature must be located in between the melting point and also the boiling point. Right, because remember, beyond the boiling point, it will be gaseous state. Between the melting point and the boiling point, there will be the liquid state. And then for below the melting point, there will be the solid state. Okay, that's the actual diagram. So based on the statement liquid at -200 degrees Celsius, the boiling point must be a greater number than -200. So the only possible answer is A, argon, which is the boiling point at -186. Moving on to the next question, 3. 2 different food colorings X and Y are tested using chromatography. 3 pure dyes, 1, 2, and 3 are also tested. The chromatogram is shown. Which statements are correct? 1, X and Y both contain 2 or more dyes. Let's check whether this statement is correct or not. Well, as you can see, X has 3 spots. Okay, which means that it is made from 3 components. And then for Y, it has also 2 spots, which means, yeah, it has, both of them has 2 or more dyes. This is correct. 2, dyes 2 and 3 are present in both X and Y. So if the dye contains, well, dye 2, it means that the chromatography result should have a parallel spot. Right, these 3 are in parallel, which means that X and Y does contain dye 2. And then for dye 3, it is also found in X and Y because you see there's parallel spots for all 3 of them. Okay, so with that said, 2 is correct. 3, the RF of dye 1 is 0.625. Let's check that out. So what's the retention factor of dye 1? It's, as you can see, what's the fraction here? So always imagine this as a fraction. The baseline to the solvent front, and then also the how far did the dye travel. So it is traveling 5 units out of 8 units, you see? Right, 5 units out of 8 units. So the fraction, the retention factor is 5 out of 8. Okay, although you can apply the formula which is taking the spot distance over the distance between the baseline and the solvent front. Okay, otherwise if you prefer to look at it as a fraction form, that is okay as well. So it is 5 out of 8 units. Right, so with that said, it's actually 0.625. So 3 is indeed correct. So the answer is 1, 2, and 3, C. Moving on to the next question, 4. Which statement about the atoms of all the isotopes of carbon is correct? So, not all of them are radioactive, so A is wrong. They have the same mass? No. In fact, isotopes of the same element have different masses due to having different nuclear number. So different mass. And then C, they have the same number of neutrons? No, because isotopes actually have different number of neutrons. So the only possible answer is D. Let's check that. They have the same number of electrons in the outer shell. That is indeed correct. Right. If you talk about atoms, carbon is a group 4 element, which means that the electronic configuration, or should I say the valence electron, is 4. And then the electronic configuration is 2, 4. Right. So all of the isotopes, right, regardless of it being carbon 12, carbon 13, or carbon 14, all of them still have 4 electrons in the outer shell. 1, 2, 3, 4. Right, in the outer shell. Okay. Despite you can actually draw the inner shell as well, but it's not our concern. So remember, isotopes, their electron in the outer shell will remain the same. Moving on to the next question. 5. Which diagram represents the structure of silicon 4 oxide? So silicon 4 oxide. First of all, you see that silicon 4 oxide, the formula is SiO2. What do you see here is that it has 2 different elements. So A and B, you can pretty much cancel these 2 answers. Why? Because you see, all of them are made from the same color of elements, which means that it's the same atom. And in fact, this is diamond, right? Diamond. This is graphite. Okay. Second clue is that the fact that, not exactly a clue, but your understanding of silicon 4 oxide is a giant covalent compound. So C is actually a structure for ionic compounds, not for covalent compounds. So D is the answer. Okay, in fact, you see there are 2 different elements. And also, if you know your silicon 4 oxide structure well, you will know that silicon is actually a group 4 element, which means that you can see that it's connected covalently via 4 lines to oxygen atoms. And then oxygen is a group 6 element, which means that if you have 2 covalent single bonds, see, right, 2 lines. Okay, silicon should have 4 lines, oxygen should have 2 lines. Okay, hence forming this giant covalent structure. Moving on to number 6, lithium and fluorine react to form lithium fluoride. A student writes 3 statements about the reaction. 1. Lithium atoms lose an electron when they react. That is correct. Right, because lithium is a group 1 element and then is a metal, so it will choose to release 1 electron when they react. Now, 2. Each fluoride ion has 1 more electron than a fluorine atom. That is correct because fluorine is a group 7 element. Okay, it's a non-metals, which means that they receive electrons, and then fluorine essentially take in 1 electron and forms a fluoride ion. So 2 is correct. 3, lithium fluoride is a mixture of elements. No, this is a ionic compound. It's not a mixture. So the best answer is A for number 6. Moving on to question 7. How many electrons are used to form covalent bonds in a molecule of ethanol? CH3OH. Let's draw the structure of methanol. So start with the carbon, followed by the functional group, which is hydroxyl group, and followed by filling the carbon with more hydrogens. And then remember, carbon is a group 4 element. It should have 4 lines. All right, let's see. How many covalent bonds are there? 1, 2, 3, 4, 5. There are 5 single covalent bonds here, which means that there are 10 electrons that are shared. So the answer for 7 is D. Moving on to question 8. Magnesium oxide has a high melting point. Carbon dioxide has a low melting point. Which row identifies the attractive forces that are broken when these compounds are melted? Okay, so for this question, you need to know that this is an ionic compound. How are you able to recognize that? By seeing whether it's made of a metal, non-metal, right? The components of magnesium oxide is a metal and a non-metal. When metals and non-metals come together and form a compound, it's an ionic compound. And then for carbon dioxide, carbon and oxygen are both non-metals. So this actually forms a covalent compound. So ionic compounds are characterized by their strong attraction between ions, right? Literally, ionic compound, right? So strong attraction between ions, not molecules. Whenever you see the word molecules, it refers to covalent compounds. And then carbon dioxide. The answer should be weak attractions, not between the atoms. You see, covalent compounds, in between the atoms, the covalent bond is strong. But in between molecules, the forces or attractions are weak, which makes the forces easily broken and hence leading to a lower melting point. So the answer is D. Okay, the attraction between atoms in covalent compounds are strong, but the attraction between molecules are weak. All right, moving on to number 9. The ionic half equation for the formation of oxygen during the electrolysis of aluminum oxide is shown. What are the values of X and Y? Now, as you can see, there are 2 oxygen atoms on the right. Okay, so hence, oxide ions available, don't get confused by the charge. Okay, it's nothing to do with the number of the ions available. So X has to be 2. Okay, 2 pieces of oxide ions. And then, because you have 2 pieces of oxide ions, in order to form a complete oxygen molecule, it has to give out 2 electrons each from the oxide ions. So one oxide ion contributes 2 electrons. So 2 oxide ions contribute 4 electrons. Right? So the answer is D. 2 oxide ions give out 1 oxygen molecule and 4 electrons in the process. Moving on to number 10. A compound has the formula XF2 and has a relative mass of 70. What is element X? Now, mass is contributed by the atoms, right? The total mass, okay, altogether the mass is actually contributed by each of these atoms, which means the mass of X, the mass of fluorine atoms, okay, there's 2 fluorine atoms here, lead to the mass to be 70. Okay, so we need to find out what's the mass of X, and then use your periodic table. Fluorine, the mass should be 19. Okay, based on the periodic table, equals to 70. So X is, the mass of X is 70 minus 2 times 19, which gives you 32. Right, so what is the element that has mass 32? That will be sulfur. Right, so number 10, the answer is C. Okay, allow me to look at the periodic table real quick, just to be sure with my values. Yep, sulfur is, yeah, the mass is 32. So the answer for 10 is C. Moving on to the next question. The diagram below shows a section of an overhead power cable. Which statement explains why a particular substance is used? Aluminium has a low density and is a good conductor of electricity. That is actually correct. Right. So the answer is A. Ceramic does not conduct electricity, so B is wrong. Steel can rust in damp air. Yes, but it's not the reason why we use it in the overhead power cable. And then steel is more dense than aluminium. Not exactly a reason why we use them in power cables, right? So the only answer possible is A. Moving on to question 12. During the electrolysis of dilute sulfuric acid, hydrogen is collected at the cathode. What is the ionic half equation for this reaction? So what we know is hydrogen ions, they come to the cathode and get discharged to form hydrogen molecules, not atoms, and releasing electrons in the process. Then translate this into a chemical equation. H plus turns into H2 plus electrons. And then all you need to do is balance it. So there's 2 hydrogen atoms on the right, which means that you need to put a 2 in front of the hydrogen ions for the left-hand side. And then because you have 2 positive ions on the left, it needs to release 2 electrons in the process. Which means the answer for this question is D. Oops, my bad. My bad. Yeah, when you do too much of questions, you tend to be overconfident and make mistakes. Yeah, it should be a positive species reacting with a negative species to form a neutral molecule. Okay, so don't be like me. Always double check your answers. Right, hydrogen ions react with electrons to form hydrogen molecules. Yep, positive reacts with negative, leads to neutral molecule formation. So the best answer is C. Okay, because mathematically it wouldn't make sense. Like, how can a positive species form a neutral species with a negative species? It doesn't make sense. Right, so the best answer is C. Okay, always double check your answers. Don't be like me, make careless mistake, which could have been avoided. All right, moving on to question 30. Which role describes an endothermic reaction? So in an endothermic reaction, the reactants possess lower energy than the products. Okay, that's why they need to suck in heat energy from the surrounding. Okay, they need to get boosted. They need to steal heat from away. Sorry, steal heat into its own pocket. Right? So it needs to steal heat from the surrounding and then boost itself to become products. So A is not possible, as well as C, because you see that reactants and products, the reactants have more energy than products, that will not be a endothermic reaction. And then meanwhile, what do we see? Okay, in terms of energy transfer, so the energy is transferred from the surroundings to the reaction. It steals energy from the surrounding. Right, so the answer for question 13 is B. Moving on to question 40. The equation for the complete combustion of methane is shown. The bond energies are shown in the table. What is the energy change for the reaction? Okay, for this question, you need to know your structures. Right, let's draw methane structure. CH4. Oxygen is OO double bond. Carbon dioxide is having this structure, double bond O, double bond O. And then for water, it is oxygen covalently bonded to 2 hydrogen. Okay, how do you know how to draw covalent structures? Always remember, it's based on a group. Carbon is a group 4 element, which means that it will have 4 lights. Oxygen is a group 6 element, which means that it will have 2 lights. And then hydrogen is a group 1 element, a little bit special, it will have 1 light. So essentially, you're drawing your stick and ball diagram. I call it that way. Okay, just make sure that the stick follow the rule of the game. This is the rules. Okay, these are the rules of the game for covalent bonding drawing. All right, with that said, let's see. Now, in order to form the products, we need to break the bonds. How many bonds need to be broken here? We have 4 CH bonds. And then we need to break 1 double covalent bond in oxygen. And then we need to form 2 carbon oxygen double covalent bond. And we need to form 2 oxygen hydrogen covalent bond. All right, so remember, breaking is like an investment. Okay, investment. Essentially, it is an endothermic process. Heat is required to break the bonds. So let's figure that out. How much energy is required? 410. Let me just write the subject first. Bond breaking is equal to 4 multiplied by 410. And then we need to break 1 oxygen-oxygen double bond. So another 496. Add them all together. Allow me to use calculator real quick in order to speed this up. So this is 2136. Right? Then we figure out how much energy is released. Okay, so remember, bond formation is like a return. Okay, return process. Your investments have returns. So it's an exothermic process, which means that you need to convert the symbols to negative. So bond formation is 2, let's see, the bonds formed here, 2 carbon oxygen double covalent bond. So there will be 2 multiplied by 805. And then 2 hydrogen oxygen bond, which means that you need another 2 times 460. Add them all together. Two 530. Okay, so the symbol's actually negative. So allow me to put a big negative surrounding the calculation. Okay, so see, this fraction, right? The investment is 2136. The return is 2530, which means that it's a good investment. It gives you back energy. Okay, so how much does it give you as a net? Right, so all you need to do is take negative 2530 plus 2136. Essentially, you just find the difference between the investment and also the return. So you will find out that the return is a 394 kilojoule per mole. Am I making a mistake here? I think I just did. Let me check whether my values are correct. Am I missing something? Yes, I am missing two things. This is scary. I forgot to multiply by 2 for the bond breaking process. So let's check that out. Let's change this number again. So this one you change to 2. Wait, let's just recorrect this so that we are okay, let's do that. Don't panic. If you realize that you spend too much time on calculations, always remember you can skip to the next question first so that you don't waste too much time on working on the calculations. So this is 2632 to be exact, right? So with that said, let's look at the bond formation part. The bond formation is you are forming 2 molecules of water. So means that you actually need to form 4 bonds of OH. All right, so in other words, you need to convert this to 4 and change this. Okay, allow me to write that type that out real quick. 805 and also what do you call it? So you get 3450 as a return. Right, so the net change, the enthalpy change is, that's the return and the investment. So it gives you a whopping 880, right? Let me double check the answers real quick. Yeah, it is A. Okay, so allow me to recap this part. Okay, so first of all, our structures are correct. The mistake that we make is we forgot to look at the coefficients. Actually, it's me lah. Okay, I forgot to look at the coefficients. Okay, so don't be like me. Always check your answers, and then yeah, pretty much have that set, and then you can jot it down here so you see the investment. I'm investing 4 CH bonds. I'm investing on 2 oxygen-oxygen double covalent bond, and then for the return part, it's returning me 2 CO bonds and then 4 OH bonds. So you just find out the bond breaking part, 4, 2, right? And then for the bond formation part, there are 2 bonds multiplied by this one. And then also these are 4 bonds multiplied by 460. So you get the answer. And then just compare them together. We see that this is the investment, this is the return. The return is better. So how much is the return then? How much is the net profit then? 880. Right? So make sure you are not, what do you call that? If you find, as I mentioned just now, if you find that you spend too much time on this question, better just skip. Okay, skip to the ones that are easier, and then if you have extra time, come back to this question. Right, moving on to 15. Hydrogen fuel cells can be used to power cars. Which statements about a fuel cell are correct? 1. The balance equation for the reaction is H2 plus O2 turns into H2O. That is not balanced at all. Why? As you can see, There are two oxygen atoms on the right, sorry, on the left, and then only one oxygen atom on the right. So it's not balanced. 2, the fuel cell generates electricity. That is literally what we want, right? That is literally the purpose of the fuel cell. So correct for 2. And then 3, in the fuel cell, hydrogen is reduced. As you can see, hydrogen receives oxygen, so it should be oxidized, right? Not reduced. And then lastly, it's the reactants are gases at room temperature. At room temperature, yeah, they are both gases, right? Hydrogen gas and oxygen gas. So the best answer seems like C. All right, moving on to the next question. 16. The apparatus shown is used to measure the rate of a reaction. Which equation represents a reaction where the rate can be measured using this apparatus? So this is a gas measurement setup. So all you need to do is to check whether the products have gases or not. So the only answer is A. This one produces a gas, which means that you can use this particular setup. The other 3 options, as you can see, doesn't have gases in the products. All right, so remember, use gas range for measuring gases. Moving on to 17. T is a hydrated metal salt with a blue color. Whenever you see the word hydrated metal salt with a blue color, you should think of copper 2 salts. Okay, they are blue when hydrated. When P is heated, water is given off, leaving solid Q. So we are heating P, which is the hydrated copper 2 salt. So when you dry it off, it turns into solid copper 2 ion. So essentially that is the anhydrous form, right? Anhydrous form is, well, white in color, remember? Okay, so it changes from blue to white. Meanwhile, R is a hydrated metal salt with pink color. So this time it's R. R is, whenever you see hydrated metal salt with a pink color, there will be cobalt 2 ions, right, in the syllabus at least. Cobalt 2 chloride, okay? So with that said, this when hydrated is pink. Then when it changes to, well, when R is heated, water is given off, leaving solid S. So R changes to S, and that is actually what happens when cobalt 2, usually chloride, turns into anhydrous form. It is actually blue in color. Okay, so let's focus on the question. Which row gives the name of P and the color of S? P is hydrated copper 2 sulfate, not cobalt 2 chloride. This will be pink color. And then S is the anhydrous cobalt 2 chloride, which is blue in color. So the answer is C for number 17. Right? Based on analysis. Moving on to question 18. Magnesium reacts with copper 2 oxide to give magnesium oxide and copper. Which substance is an oxidizing agent in this reaction? So the oxidizing agent that is involved in a redox reaction actually is undergoing reduction by themselves. All right, so which one is undergoing reduction? There will be copper 2 oxide because it loses oxygen, you see, it changes from copper to oxide, the oxide form, into the metallic form. So the answer here is copper to oxide. The answer for number 18 is B. All right, moving on to the next question. 19. Part of the periodic table is shown. Which element forms an acidic oxide? The keyword here is acidic oxide, which means that it is a non-metal oxide. Right? Non-metal oxides are usually acidic. So these are metals, so they form basic oxides. So the answer is B. D is not possible because they are noble gases, they don't form oxide. All right, moving on to question 20. When aqueous sodium hydroxide is added to a solution of metal ion, a gray-green precipitate forms which dissolves in excess to form a dark green solution. Which is the identity of the metal ion? Now, sodium hydroxide is commonly used as for cation test. So cation test reacts with usually the metal ions. Now, it forms a gray-green precipitate. When you see the word green precipitate, you should think of either of these two ions, iron 2 or chromium 3. So with that said, you should eliminate iron 3 and also copper 2. So it's either A or B. But you see the last part, which is it dissolves in excess to form a dark green solution. So that is actually a characteristic of chromium 3 ion. The answer is A. All right, moving on to question 21. Which statements about strong acids are correct? The keyword here is strong acids. So one, they have a high concentration of hydroxide ions that is actually characteristic of alkali, strong alkalis. So this is actually hydrogen ions to be exact. Two, they have a pH value of 1. All right, that is, a characteristic of strong acids. 3, they completely ionize in water. That is correct. Okay, it's a characteristic of strong acid or alkali. The keyword here is strong. So 4, they turn red litmus paper blue. That is actually the wrong. It should be the opposite, blue to red for acids. So the answer here is C, 2 and 3. Moving on to question 22. Metal X reacts with non-metal Y to form an ionic compound with the formula X2Y. Which statements are correct? Now, the former element, remember, should be the metallic element, and then the latter element is the non-metal. So, based on this formula, right, we are able to deduce that, not actually deduce, conclude that X carries a +1 charge, and then Y carries a 2 minus charge. Because the construction of ionic compound formula is you cross the charges, cross the numerical values. So X should have a +1 charge, and then Y should have a -2 charge. So X actually belongs to group 1 of the periodic table, and then Y belongs to group 6 of the periodic table due to the charges. So the answer here is 1 and 3. So answer for 22 is A. Moving on to the next question, 23. The table gives some properties of group 4 elements. Which row describes the properties of silicon? Let's observe the trend here. In terms of density, we see that down group 4 elements, there's an increase in the density of the elements. Meanwhile, in terms of the trend of boiling point, we see there's a decrease. So you just need to fit the puzzle, fit the trend. So density for silicon is between 2.2 and 5.3. And then the boiling point should be between 4827 and 2830. So the best answer for this should be A. Right. because these two values actually fit the trend. Right, so that's the answer for 23. Moving on to 24. The metal beryllium does not react with cold water. It reacts with hydrochloric acid but cannot be extracted from its ore by using carbon. Where is beryllium placed in the reactivity series? Oh, okay. So first, it reacts with hydrochloric acid, which means that, well, this is a metal displacement reaction. So it should form something like this. Okay, based on assumptions, okay, based on the general rules of metal with acid reaction, it should produce a metal chloride and also hydrogen gas. Okay, this is more of a general assumption. So I don't have the balance equation, you see, just for us to refer only. And then for the second part is it cannot be extracted from its ore by using carbon. Let's write that down. What is an ore? Usually is the oxide form. Okay, oxide form. So beryllium oxide. So this fails to occur. Now, what does this tell you about the reaction? You see, in the first equation, first reaction, beryllium is able to take over hydrogen's place. It displaces hydrogen out and leads to this formation. So it means that beryllium is actually stronger than hydrogen. Of course, in exam, don't write that. It's just how I describe it. It's more reactive than hydrogen. Okay, on this, the second equation, okay, although this is, there's no chemical equation that's happening here, you see that carbon fails to take over beryllium's place. Right, expected outcome is carbon is able to displace the metal out and then forms carbon dioxide. But that doesn't happen. Means that beryllium is stronger than carbon. Right, it's more reactive than carbon. Now, our understanding is carbon is more reactive than hydrogen actually in the reactivity series. So essentially, okay, let's combine these two, some like inequalities, So essentially, beryllium is stronger than carbon and also stronger than hydrogen. And carbon is stronger than hydrogen. So essentially, you get this conclusion from the statement. So which answer is the best? If you know your reactivity series well, you should know that zinc is below carbon. So let me restructure this. Carbon is more reactive than zinc. So it means that beryllium is way above copper, it's way above iron, it's way above zinc. So the best answer here is A. So for this question, right, you need to understand the statement, form your own conclusion regarding these three elements, beryllium, carbon, and hydrogen. Which one is more reactive than the other? Then also based on your memorization of the reactivity series, that the fact that carbon is more reactive than zinc. So you have to place beryllium even above zinc. All right, so the best answer here for question number 4 is A. This is not an easy question because it relies on your memorization of the reactivity series and also your understanding of the displacement reactions. Now, 25. Why is cryolite used in the extraction of aluminium from bauxite? Because cryolite has three purposes. One, it acts as a solvent for aluminium oxide. And in that process, it helps to improve electrical conductivity as well as able to allow the procedure to be operated at a lower temperature. All right, so the best answer is B. No, it does not act as a catalyst. It does not stop the carbon anodes from burning away. And then it does not reduce aluminum ions. Right? The only purposes of cryolite is these three. Right? Moving on to 26. Which statements about the uses of metals are correct? 1. Iron is used to make aircraft because iron has a low density. Transition metals are very heavy, are of a high density. So we don't use them in, that's not possible, right, for us to use iron to make aircraft, maybe some of the components, but not, not the entire aircraft, right? Because it has high density, it would have sunk if we were to use iron, right? 2, copper is used to make electric cables because copper is a good conductor of electricity. That is absolutely correct, right? That's why your wires, like the wires in my headphone, is made from copper. 3, aluminum is used to make brass because aluminum is strong and hard. Brass does not contain aluminum, right? So that's wrong. And then lastly, iron is mixed with additives to make an alloy used in chemical plants. That is actually correct. Right. Iron can be used to make steel, for example. Right. So the answer for this question is D, 2 and 4. Moving on to question 27. Which role describes the reaction of magnesium hydroxide and magnesium oxide? All right. So this one relies on our understanding on magnesium as a metal. If you remember your reactivity series, magnesium is pretty reactive. Okay, what's the downstream event of that? Magnesium oxide is extremely stubborn. It's really hard to reduce magnesium oxide. So when you heat this with carbon, no reaction will occur. Remember the reactivity series from the previous question? Carbon is below magnesium. It's not as strong as magnesium in terms of reactivity. So there will be no reaction for heating the oxide of magnesium with carbon. What about the hydroxide? Well, metal hydroxides in general, when you heat them, they form oxides. So the answer for this question is B. All right, generally, metal hydroxides, when you heat them, they do release oxides. Okay, and some of the byproducts. Moving on to question 28. The properties of an element are listed. Its melting point is 3,414 degrees Celsius. Some of its compounds are catalysts. It has variable oxidation states. Okay, so whenever you see these two words, you should think of transition metals or transition elements. And then they also have high melting and boiling points. Right? So moving on to question 29, petrol burns in a car engine to produce waste gases which leave through the car exhaust. One of these waste gases is an oxide of nitrogen. Which statement describes how this oxide of nitrogen is formed? So it's how oxides of nitrogen are formed in the car exhaust. It's by nitrogen reacting with oxygen in the car engine. Okay, it is an unwanted reaction, but it happens in the car engine and forms these toxic gases, nitrogen oxide of nitrogen. Okay, and then they are processed in the catalytic converter. Okay, this process does not occur in the catalytic converter. All right, moving on to question 30. Which combination of chemical compounds can be used to produce the fertilizer shown? This is an NPK fertilizer. Well, how do you make NPK fertilizer? Using chemicals that contain these three elements. So just check from the answers which of the following has these three elements present. So the answer is A, right? Because this one is N, this one is P, this one is K. B doesn't have K. C also doesn't have potassium. And D doesn't have phosphorus. So the answer is A. Okay, in order to make NPK fertilizer, of course, you need compounds that contain these three elements. Moving on to question 31. Which process does not produce carbon dioxide? Combustion of a hydrocarbon, yes, that produces carbon dioxide and water. Photosynthesis actually consumes carbon dioxide, right? It does not produce, it consumes carbon dioxide. So B is the answer. Let's double check everything. Reaction between an acid and metal carbonate, that yes, that actually produces carbon dioxide. And respiration, which is us breathing in, breathing out. Okay, cellular respiration, or you can see our whole body, breathing, right? We do produce carbon dioxide. Moving on to question 32. Which substance is used as a bleach in the manufacture of paper? There will be sulfur dioxide. You kind of need to memorize this in order to know the answer. Right, the answer is sulfur dioxide. Moving on to 33. What is an industrial use of calcium carbonate? So calcium carbonate is used in manufacture of cement. As you can see, question 32 and 33, you kind of just need to know how do we do it in industry. All right, moving on to question 34. Propane reacts with chlorine. Which row shows a condition required for this reaction and identifies the type of reaction? So alkanes can only react with chlorine in the presence of UV light. Because alkanes are very unreactive unless you subject them to UV radiation. And then it's not an addition process, but a substitution process. Right? The hydrogen bonds get substituted, gets replaced to the having halogenic groups. Right, see this? Hydrogen gets displaced. Sorry, gets substituted, to be more precise. Right, moving on to question 35. The pie chart represents the composition of natural gas. Which sector represents methane? There will be D. It's the major component in natural gas, right? Methane. So the answer is D for question 35. Moving on to question 36. Which statement describes the reaction between ethene and steam? So ethene reacts with steam, which is just water in gaseous form. To form ethanol, which is having this structure. Essentially, you copy this and paste. But instead, these two are added to the ethene structure. So it's an addition process which produces ethanol as the only product. Okay, cracking is for long chain hydrocarbons. And then it's not exactly an oxidation process. And this is not a slow reaction because it's a catalytic addition. Okay, essentially we're using catalysts to help to increase the rate of reaction. Moving on to question 37. The formula of a hydrocarbon is CXHY. The equation for its complete combustion is shown. What are the values of X and Y? So X refers to the number of carbon atoms and Y refers to the number of hydrogen atoms. If you see, just look at the left-hand side. The carbon atoms are only present in the carbon dioxide. There's 5 of them. And hydrogen is only present on the right-hand side as in the form of water. So in total, there's 12 hydrogen atoms. So X is 5 and Y is 12. Pretty straightforward, but you need to be able to read it from the equation. Moving on to question 38. The formula of an ester is that thing. Which acid and alcohol react together to make the ester? Now, the strategy here is cut between CO and O. This one. The one with the CO originates from the carboxylic acid. The one with the O originates from alcohols. So with that said, right, you see both sides contain 3 carbon atoms, which means they are having the prefix. No, wait. For the carboxylic acid, there are 4 carbon atoms. And then alcohol, there are 3 carbon atoms in total. So what's a 4 carbon carboxylic acid? There will be butanoic acid. And then what's a 3 carbon alcohol? There will be propanol. So the answer for this question is B. All right. So make sure you check the answers. Yeah, you check this one. There's actually 4 carbon atoms on the left. So there will be butanoic acid. Moving on to question 39. Molecule 1 undergoes a process to make molecule 2. Which row describes the molecules and the process? So for this question, it's pretty much an open question. You will need to check one by one. So let's see. Monomers get cracked into polymers. That's wrong. That doesn't make sense, right? Monomers are smaller. How can it be cracked to form bigger molecules? Right, monomers are smaller, polymers are bigger. So B, monomer polymerizes to form polymer. Literally, right? Polymers. Poly means many. Okay, so it is undergoing polymerization to form polymers. So the answer is B. Let's check for C and D anyway. Small molecule gets polymerized to form monomers. Sounds a little bit off, not exactly accurate. And then last thing is small molecule cracks into monomer. Not exactly accurate. The word small molecule is just too general. So please don't write this in your paper 4 in terms of, let's say, a similar question appears. All right. Last question, finally. Which structure represents a protein? So a protein is made from amino acids. So protein is a polymer, which means that it has multiple monomers grouped together. And then amino acids, there are many types. So essentially, it's like a color beads joined together. So amino acids are the monomers. So what are the clues here? Essentially, they must have different units. So C is not possible. Right, all of them are the same color. And then B is also not possible. Right, because amino acids have this structure, you see, if you still remember. That's the structure of an amino acid. So the terminals, one is having an amine group, the other one is having a COOH group. So these two are wrong because you see the terminals doesn't make sense, right? Where does this go? This is not found in B and C. So B and C are not possible. So it's either A or D. All right, you see, it should be CO joined to the next amino acid by NH. Right, one amino acid, both terminals are different. Okay, so CO for one side, NH for the other side. And then CO, NH, CO, NH. It shouldn't be like this. Right, it shouldn't be like this. This one, the same terminal. No, amino acids have different terminals. So the answer for this is A. All right, question 40 is A. Okay, that's the end of the discussion. Thank you so much for watching. I apologize for the mistakes that I made just now. Okay, but I do hope that this helps you in your exams. And then I'll see you in the next one. Why am I suffering? Yeah, but see you in the next one. And thank you so much for watching.